Fujitsu. He's an SE for Fujitsu. He does VRF only. Been doing it 13 years. I'm Kevin from Top Marketing. I think most of them met me. Brad. And I do H and B and J. I do all of it. So Reed can too, but he mainly is VRF. So we're just kind of giving you some information to get you guys to look at VRF more. We can do a little bit of everything. So I'll leave it up to Reed to go over it.
Okay, thank you. As Kevin said, I've been here with Fujitsu as a sales engineer for 13 years. I've been on all kinds of projects, started before we even had VRF here in the United States, North America. So seen a lot of different changes, but also I work with, as Kevin said, with some of the H series, mostly on odd things. Maybe if we have multi-family residential, if you want to bring outdoor air into a ducted unit, how much of that outdoor air could we do with this ideal work? Then that type of engineering or calculation or application engineering is what I would get involved in. So we're going to talk about, to start out, difference between mini splits and VRF, and some things for you to consider. I don't want to get too deep into it, but then kind of in the industry, nobody ever really wants to get too deep into it, and then we find out that they don't have sufficient knowledge to really make a decision. So I'm hoping it's not too in depth, but it's things that I think, because I cover a large territory, a lot of jobs, but I cover a large territory from my home in northern Kentucky. So I go all the way out to North Dakota, South Dakota, Kansas, Nebraska, Missouri, and Iowa, and Illinois, Wisconsin, and Minnesota, and Ohio, and of course my home state. Oh yeah, Indiana, can't forget Indiana. And did I say Illinois? That's where we are, aren't we? I don't even know where I'm at anymore.
Across the river.
We're in Missouri, that's right. Yeah, crossed over, yeah, that's right. I guess that was that big thing of water there. And then also I cover coast to coast, the whole country of Canada. So, which sounds like a lot, but really it's all the population is on the eastern side of the country and the western side of the country. And then the prairies is just kind of what it is. So we have looking at VRF or mini splits or zones, but it's comfort. Comfort's what we're selling. Nobody really wants to buy HVAC equipment. What they want is to be comfortable. Cool when it's hot and warm when it's cold, and that's what we're doing. So how we do that is how well we do in this industry. So we provide the ability with individual units, cassettes, wall mounts, ducted units. We have a lot of options on those to meet the various needs of a given application. Now, one thing to keep in mind when you're working with your customers, when you're talking with a contractor, or you're with a contractor who's looking on the job, or you're trying to work with them on the bill of material, ask them what are their customer, their actual occupant who's going to be in the space, what's their temperature and control expectations. So how are they expecting to control their HVAC system? Because in the black there, never place a multi-zone heat pump product across multiple dwelling units. Someone's going to be unhappy. And what is that? Well, you have a multifamily residential, or where I've seen it happen even more often, an assisted living facility. Use one of our 4 zones on a heat pump. The first call in puts that heat pump in either heating or cooling. If you have assisted living, you've got maybe a 70-year-old grandfather and who's a widower, and he's over here. And then on the other end of the zone is a 92-year-old great grandmother. and she had a few health problems, and they're coming in and they're paying $5, $6, $7,000 a month, the family. And there she's all with her favorite quilt that she melted, but did it back in 1960, and she's all wrapped up because she's freezing because she wants to be heated. But you know what? Can't give it to her because the first call in and going back and forth, that's not going to work. So individual single zone H series or mini splits would have been a better choice. Of course, you contend with all of the issues with that, all those outdoor units, all that equipment, electrical runs, breaker spaces on the electrical side, all of that. But we have to know that because I've been on jobs, I've been out to Iowa, I don't know if I mentioned that's another one of my states, and I had that exact job. And so that job was doomed the moment they ordered the equipment because they didn't think about what is the customer's expectation. So this isn't so prevalent, even though it's the same concept with a rooftop unit, because we all know that a rooftop unit or a ducted type of furnace and split system, that's all you're going to get. But they understand that as soon as they see individual units, then the mindset of the occupant is, oh, I can select. Well, why can't I select it to go any cooler? Because then that brings up another type of system called variable refrigerant flow, VRF, and in particular, heat recovery. So, but we will get into that. So does everybody feel comfortable with that? And then the other thing with the control, we're gonna remind you, Kevin, to get one of those pointer, things, but the control expectations, are they going to want to have some central type of controls? You have a church you're going to do, and you have the rectory or the parsonage that's attached to it, and that's one occupancy and maybe one system. But then there are the 3-ton systems, 3-ton cassettes down at the fellowship hall or the multi-purpose center. And then you have individual offices, all with different equipment. If you're going to a mini split or an H series, there's no offering that Fujitsu currently has to be able to put those all in one central controller. We could do that through the VRF side on our controls, which I'll talk about in just a little bit. But overall, as an H series product, there's no control that would do that. However, on the VRF side, we have centralized controllers that will sit across refrigeration circuits and allow that occupant or that manager or whoever's going to control that to go to that controller and say, I want that room at this temperature, I want this one at this temperature, this one at another temperature. And if it's hooked up to heat recovery, you can determine if those are going to be in heating or cooling. So that's called a centralized control. So when you're working with your contractors or talking with them or talking about an application, ask them, okay, what you think you're going to need a central control? Well, what is that? It's going to sit on top of everything, give you one point to control things. And the reason why I say that is because when we start out with J7S, which is our 2, 3, and 4 ton, that is where the Fujitsu product lines are.
Do you need me to read the order?
We have 2.
Because I need to go through and delete stuff off the order. Do you need a print?
Both single zone and multi-zone on the H series, and then we have 2, 3, and 4 ton on the VRF side. So where in that product spectrum do we need to direct this contractor, this customer for their applications? All right, so here we're just going to have just to start the conversation. This is has to be an office building. It could be a larger custom home, doesn't really matter. But it's got 3 heat pumps in it. And you can see the top, the 3 rooms or offices at the top and the conference room on the end. And then 3 offices at the bottom. And then maybe the washrooms there, whatever. It was just some things that I selected. And Then we have, the application is multiple multi-zone systems. The end user may be expected to control all of the indoor units via one controller. Okay, this would be the centralized controller. It's going to see all of those units across all refrigeration circuits, can see up to 100 units, 100 indoor units, and allow control each one of those with different time programs, different temperature programs that are going to be entered into the controller. Our H series side does not offer this feature, but its J series cousin does. And I'm going to explain that to you. Because also that J series now, we've completely sold out of all of our J4. So now we're at the J7S, which is an R32 product, which brings into the application all the A2L requirements. So we're going to briefly go over that. So we always want to ask if controlling all the indoor units from one location is a benefit that they want. It's a benefit, does Mr. Building Owner or whoever's asking us to do it, do they want to have that? Now, we get into VRF. Be very careful. I have had this happen. It happened in Indiana. I noticed I spent a lot of time in Indiana, but at this job, it was a electrical co-op. The name escaped. I want to say Bartholomew County. Is that right? Can't remember what that county is. Anyway, the owner came to the contractor and said, "I want a VRF system. We were expanding this building. We got VRF over here. We want a VRF system." The contractor says, "Great." He does a load. We select the system. Everything's good. They go to install it. I'm there to do the startup and then also the owner training with the contractor. And we're showing them on the controllers. And then the manager said, "Okay, I want to see it go into heating." Okay, so go up to the central controller, put everything into heating. Okay, it's heating. Okay, now I want to see this office in heating and that office in cooling. And I said, "Okay, can't do that with this system." Well, that's what I want. And then you can almost see the beads of sweat on the contractor, the project manager, because when they said, they, being the customer, said VRF, and they said, like this system, the question was never asked or was investigated that, do you want heat recovery VRF, heat pump VRF? What got installed was heat pump VRF, all in heating, all in cooling. You're going to be either calling for the compressors to run and take the refrigerant, or you're just going to be circulating the fan. So they had to add boxes, add a third pipe, take out the other units, the other outdoor units, replace them with heat recovery units, and the owner got what they wanted. So be sure as you're talking with the customer what you want to have. And if it's an occupancy, a hotel, multifamily residential, not so much dormitories, not so much nursing homes, because the expectation of the occupant isn't to have that specific selection when they're in that room or that zone to make their choice. Me, last year was 82 nights in hotels. And there's sometimes I walk in my personal physiology, whether I'm under stress or whatever, and I want to have it cold. I want it to be cold, so I want it to be in cooling. Other times I've come off of roofs and looking at jobs in the wintertime. I've been with our equipment at negative 27 degrees Fahrenheit, standing temperature, dry bulk, not wind chill. Our units are still running, but when I came off that roof, I was absolutely freezing. So I want to select my choice for temperature. That's the case, that's going to be heat recovery. It's going to be heat recovery at this point now in the industry, except for, I think LG has one, and maybe Carrier or the private label company that was doing for Carrier other than Toshiba. They have single phase heat recovery systems, but that's going to drive the system to single phase. So that's going to ask the question, you have three-phase power at the building? So that's kind of where these things, so it's just not too deep, but just understanding the product enough that, okay, I think, and you start to look at bigger systems and think, okay, what do I have for electrical supply? So heat pump or heat recovery. And heat recovery is nothing more than condensing the hot gas off the compressor through this third component, which is called a refrigerant branch unit, others call it a branch controller. But taking the hot gas off the outdoor unit, going through solenoid valves in the RVU, and then turning that indoor unit into a condensing coil, a condenser, rejecting the heat, just like a condenser always does, and then taking that high temperature, high pressure gas back to a liquid. And then that liquid, because of pressure changes in the piping, is able to go to the next office because it's a liquid measured through the electronic expansion valve. It then begins to evaporate it, and then we get cooling, just like a normal evaporator. And so that's what VRF does. The beauty of that is that there are some times if you have an equal load on heat recovery where you have roughly the same amount of BTUs in heating as in cooling, the compressor becomes merely a device that's going to create a pressure differential in the piping and then allow the equipment to just move that refrigerant, liquid, back to gas, gas going through the compressor back to liquid, and then the energy consumption, or back to a liquid, and then go back to a high pressure gas, and then go back to a liquid, and then that will then limit the amount of energy. So we're truly recovering BTUs in one side of the building and moving them over to another side of the building. Any questions on that? Seem like that's pretty clear? Okay. So then, knowing how our equipment works. So in VRF, and so that would be J and V series, like in H series or mini splits, the first call in sets the heat pump in whatever mode. And there are three ways on our VRF side to change this. But H series doesn't have the other two. The second is external input to an outdoor unit. So you can have a third party control, you need a connector kit. And if we know that a building needs to go into cooling when the temperature gets up to 48 degrees outside, well, then we set that up. And that sends a signal into the unit, and the unit stops and it changes mode. And then the next thing is setting an administrative indoor unit. Very important. On every heat pump circuit, there will be an administrative indoor unit on the VRF side. And that says that of all of these controllers in this application, which one best represents the zone? Because then when you have an administrative indoor unit, the manager or occupant or owner can go to that administrative control and select what mode, kind of like what would be a centralized controller. So you wouldn't have to go to the full size of a centralized controller. You have just one heat pump outdoor unit on the job. Sometimes they do. I have many systems like that, but you wouldn't have to because you have that administrative indoor. But the administrative indoor unit gives you an additional mode. So you have cooling, dry mode. Does everybody know what dry mode is on a mini split or a VRF? Okay. Looks like everybody's shaking their heads. Yes, got that. Okay. Then the cooling, dry mode, heating. Then the fourth mode is custom auto. And that is on the VRF side, that is a dual set point control, so that changing this controller to sense at the remote. And then selecting custom auto, and you can set a 72-degree cooling, 7-degree heating, 2-degree deadband. And that's adjustable, that deadband, and that will automatically go back and forth to change the outdoor unit from heating to cooling. Again, there's that level of control expectation. And then the other thing that I want you to think about, because I said that heat recovery brings you into the 3-phase realm that may not be available. So I want you to think about zoning by heat pump circuit. So a total tonnage comes up for a given structure. It doesn't matter if it's a large home or small for that matter, or an office building, but there's some heat loss, heat gain, and that's going to be some number of tons. Well, then it's looking at how can I take those same 3 heat pumps and meet my load. And if we look at this, we can see that, okay, the heat pump is down here and it's hitting all of these. And A is up there, that third one goes off somewhere. And we're looking at this and saying, okay, that's not bad, but is that really the best way? No, because as the plant, we've got offices that do not border on exterior walls. So they're not going to need to go into heating, and depending on what's happening in the conditioned area, that may be some type of heat in there. I don't know, maybe there's skylights, whatever's going on in there, but it's some type of conditioned area. But these may need to go into heating. And if this is the east side, they need to go into heating earlier in the morning, or I should say later in the day, or going to cooling earlier in the morning when the sun's coming in. So it's looking at those exposures. So how could this same application be any different? Everybody see what I'm talking about here? Because when you go to from on VRF with heat pump and heat recovery, now you're getting a pretty big price increase as far as the equipment, what's going to happen on the job. Probably 35 to 37% higher costs on the equipment to the contractor, not including the additional piping. Fujitsu is a 3-pipe system, which I will show you. But it doesn't matter if you're going up against Mitsubishi, because I haven't had a job yet that I can't show a contractor that just because 3 is greater than 2 means they're going to install more piping. But nevertheless, that's the perception. And then their labor, because they're going to have to install that third piece of equipment, which is the RBU box. The indoor units and the outdoor units will still be the same, but there's that third component, and there's just a lot more of the control wiring with the RBUs indoor. So this is one option, and probably not going to be the best for the customer. But then we look at that same thing and say, okay, I'm going to make B my interior zoning by heat pump, assuming that these offices and those offices, now we have the corridor in there, so those offices are going to have a similar load profile. Again, we won't get into doing all of the load calculations, things like that, but my estimation is that these 3 offices, those 3 offices are going to be very similar to when they need to go into heating and cooling. So let's put B in the interior zone, because, and with VRF, we can definitely do that, because we can easily handle 6 individual cassettes or wall mounts. And then we'll put A on the outside. And that's assuming, again, what the envelope is, how resistant to heat transfer, how much glass, all of those types of things. But there still is with that conference room, and that's kind of the thing that's out of left field. We don't know what's going to happen there. So on that C or change C from going to whatever's happening over here. And then take C and say, all right, I'm going to put a small, maybe an H series in there and handle that conference room so that it will always be comfortable for that end user. Does that make sense? That's how you sell heat pumps. That's how you sell the comfort level that everybody wants to buy. And that's how the contractors and your customers put themselves a step above maybe the next guy or woman that's coming in that's making a sales presentation, because in my experience, I've been in HVAC for 45 years. And I was part of a family mechanical and electrical contractor. I did all the design, build, engineering for it, then worked for a couple of large contractors. Then 13 years ago, came to work for Fujitsu as a sales engineer. And I was always looking for, when I went into that customer, I could see in their eyes what they saw was show me duct list and a price. And then here's mechanical service and a price. Has to be a way to differentiate that piece of paper when they come down to making that decision, unless you ever make a decision right there in front of you. So that's what we're talking about here, is just elevating the thought process a little bit higher with a little more knowledge to understand how you really need to sell heat pumps. And the flexibility, there's nothing wrong with having that lone unit in that conference room, because hey, your conference room is now going to be comfortable. It's got its own 7,000 or 9,000 BTU unit. Man, that's great. It's always uncomfortable. We have our Monday sales meeting. Everybody's always complaining. Any questions on that? Everybody kind of get that thought process? Okay. What is the difference between VRF and mini splits? Many don't realize this. Many contractors don't know about this. But a VRF system does not use home run line sets. So we have an equal number of zones here, 5 and 5. Actually, that's 6 and 5. So we have a home run line set from each one of the indoor units, which is great. I mean, that's no problem, except when you get that church, that historical building, that homeowner that doesn't want to see all those line sets. They don't want to see it. So, and maybe this is a 3-ton. So if we think about the J series, where we have a 3-ton, it is a heat pump product. It has a liquid line, a suction line, but now we have separation tubes that allow us to branch off within the space. Or we have a header kit that allows us to come from the outdoor unit to one spot within the structure and then branch off. It's kind of like a hydronic manifold, and then send the pipes out to the indoor units. That's number one. No home run line sets with VRF, and we have one for each indoor unit on the mini splits. That's true for any manufacturer. And along with that, that means that from a service aspect, but also on an application aspect, the electronic expansion valves for mini splits are located in the outdoor unit. So if your application, if the contractor comes to you and says, man, I've got to run 200 feet, I've got to run 150 feet to reach this zone, you're going to run into troubles with a mini split, because once we're past that electronic expansion valve in that outdoor unit, now we are a subcooled liquid line, and the length of that can cause a change of state in the refrigerant because of pressure drop. And if we start to do that, when we get to the actual indoor unit, we lose our net refrigerating effect. We're losing the cooling ability, because the maximum amount of BTU absorption with a refrigerant is when it changes state, when it goes from liquid to gas or gas back to liquid. That's the most number of BTUs. So if you have, because of having electronic expansion valves here, you have limited line set lengths. And I'm sure you've seen in our tables and other manufacturers' tables, okay, we have to have this aggregate total. No one of these zones can be longer than this. It can't be shorter than this number. And there aren't the same types of limitations, as many limitations. There are some limitations with the J series product and also the V if doing a smaller job. But with that product, as there are with the multi-zone, we already talked about the control. So both product lines, H and or all three product lines, will use that same Kagami controller. I'm going to show you that, or the Z5, and I'll show you that. But this will allow you to go much further in line set length. So that's something else. All right, the customer's really not liking this. Typically, and then not so much lately, but the price point in those 2, 3, and 4 ton, it used to be that the VRF was not a big jump, but it was more expensive. And what I would see is work with distributors. Distributor would quote this to the contractor, then these other questions would come up from the contractor discussing their proposal with the owner. But they would see the price, then they say, oh, I want the central control. I don't want to see all these lines set. Oh, we can go to the J or the J series. And then there would be the price point. But in the customer's mind, they already saw this. They were kind of liking that. They wanted these others. And then we would end up competing against ourselves with our own family of products. We don't want to do that. So by asking these questions ahead of time, we can say, all right, we're going to go in with that. If the customer doesn't like the price, you say, wow, I don't know. Okay, well, now you could do this, but you're sacrificing this, this, and this. And they say, no, the value is there for me to, I want those things. I understand why I need to pay more for it. Does that make sense to everybody? I see this happen quite often in that 2, 3, 4 ton size. And it's so easy just to ask those questions. And other thing as far as the installation. So this system would take one 2-pole breaker going to feed the outdoor unit, and then from the outdoor unit to each one of the indoor units is going to be the 3-conductor power line, as well as that control communication cable. Everybody familiar with how that feeds from there, because you sell the components, the cable that does that. So this installation only requires 2 circuit breaker spaces. J series is different because you're going to have, it's still single phase, but you're going to have 2 poles for the outdoor unit and 2 poles, a 2-pole circuit breaker, I'm sorry, and need 2 circuit breaker spaces to panel, and then a 2-pole circuit breaker to feed all of the indoor units. There's a couple models that need to be set up on their own, but none of them really draw that much that you could put them on one 2-pole circuit breaker. So when the contractor is looking at switching from one to the other, and now he's come back and he's working up his quote, 2 poles here, or 2 breaker spaces required in the panel here, 4 with the J series. Does that make sense? That could be the difference because, oh, we don't have that. The panel is packed. I'm now going to have to get an electrician, maybe put a sub panel, move some circuits around to get the spaces. But you just can't jump from one product to the other without knowing those few nuances. Does that make sense to everyone? Okay. And then of course the line sets we talked about. So that's all the differences, and that is between a multi-zone and a multi-zone mini split and a VRF product. The if you're doing 1-to-1, say you're going to have a 2-ton system and, or a 3-ton system, and you're gonna go to one air handling unit, and you're going to have one of our H series, going to one air handling unit. There, pipe length limitations come into play, but also electric heat. I'm gonna show you that in a slide here. So be sure to ask the customer, okay, what are you looking for with the single zone system? Do you need a longer line set length? That's gonna drive the choice to J series, that long line set length. Over what might happen with the multi or single zone system, because the EEV in a mini split is located in the outdoor unit, and the EEV in the VRF is located in the indoor unit. So we have a true liquid line going all the way out to the indoor. Does that make sense to everybody? Is that anything new? Does that or help to kind of drive it home? I hope so, because I do this for everyone, because then that kind of leads us into when you're looking at product, because my opinion, it's really boring just to sit and look at pictures of product. It's what each one will do, because again, the product that you're selling here for Johnstone, the product that a contractor is selling to their customer is comfort. And they want to know how best to achieve that comfort. So we had the J4 and J4S, which were our 410A systems. Those products are completely sold out. We told Japan that we would sell out what they didn't believe us that we would have it all sold by May of this year, and literally the last order came in at the last week of May, and all of that is gone. So if you are going to go to the J series side, it's going to be an R32, which is A2L type of product. I'm going to talk to you about that, what that really means. So those are going down to a lower temperature. They have a factory base fan heater, and the indoor units on the 410A are not going to be compatible with the R32. So what's new for us, we lost the 5-ton because in all of the federal requirements and the EPA and all that stuff, anything that was greater than 54,000 BTUs, hence why we've got this cutoff here. Anything that was greater than that had to be how was that? We couldn't do the 6 or the 5-ton because that was going to come out with our larger chassis. That was a Fujitsu decision. But everything lower than that, so we have our 48 and 36 like we had with the J4, but we added the 2-ton. So don't underestimate how applicable this 2-ton is going to be in your residential market, because we're going to be able to go up to 5 zones on that 2-ton. And on the VRF side, we offer a 4,000 BTU indoor unit. So you think, wow, the 2-ton, that's pretty small, and 5 units. But with a 4,000, many of the contractors looking for in that bedroom where our multi-zones, a 7 was just too much, and you really wanted to have something smaller. Well, you can get that smaller unit with that smaller indoor unit with J series, J7S, but also in a 2-ton model. And why is that important? Multi-family residential. One of the requirements on multi-family residential is they want to have individual power metering. So they need something small enough, but we've got to have something with long enough line set lengths. We've got to have something that can handle long up, long down from the indoor unit to the outdoor unit. And we need to be able to handle 12,000 BTU and 18,000 BTU connections because of the heat loss, heat gain of the typical apartment or condo. So that's why for a single multi-position duct connection, which we're just coming out with the multi-position units, we can go down to a 50% connected capacity. So that means that small apartment or that multifamily residential or that dormitory or nursing home where you're gonna put things on the roof, you now have long line set lengths, -15 heating. And with not a significant drop off when we get down to -15. And be able to have centralized controller, be able to have the Kagami control or the Z5 controller. So that opens up quite a few things. And I'll be honest with you, the manufacturer that dominated in that, and we saw that, and Fujitsu realized it, was LG. They offered a 2-ton for multifamily residential. Every time we saw it, we would try to use our J4 3-ton and heavily discount the price, but all the electrical, all of that was it just wasn't compatible. So some jobs we got, others we didn't. So we lost the 5-ton, and that hopefully will be coming out with the larger equipment. But we picked up the 2-ton. Any questions on that? Okay. So this is our indoor unit lineup. And so you can see right here, we've got 4,000 BTUs. So that 2-ton becomes a very viable option. It's R32. So I'm going to show you something here you've probably already seen on the slide. But we're going to have the cassette, wall mount. These are all available right now. This is now just coming out. And then our ducted units are going to have the leak detection sensor built in. Because in the calculation of applying R32 A2L refrigerants and the duct size and all of that comes into play as volume. And so Fujitsu on our ducted units have added the leak detection sensor. But those are all our choices. And eventually the whole product will come all the way out here where you will have, just like, and I've sold bunches of these, Kevin has sold bunches of these. Those are the multi-position, the ARUX, a multi-position air handling unit at that 4-ton size. Available with a Fujitsu part number electric heater. Okay, so, and why is that important? I'm going to show you here, so just bear with me as the slide comes up. Be in a couple. With this R32, this is the first time probably you're seeing this with Fujitsu, and Fujitsu has just introduced these products or these components to go with the R32. But now, how familiar is everyone with an R32 calculation? Nobody's familiar with it. Okay, and that's not uncommon. I went with top marketing into Indianapolis, and we called on some engineering firms with one of Kevin's colleagues. And I asked that question of the engineers that are designing, and I said, how much do you know about R32? Zero. We don't know how we should be designed or what we should be designed. And I thought, wow, being an engineer, I just thought, I mean, this is going to be huge, because here in the United States, R32 is already happening. Up in Canada, because we sell quite a bit of our product in Canada, there are, and they stock quite a bit up there. The R410A is probably going to be running out about maybe July, maybe early August. And then when I'm talking to the contractors up there, I was out in British Columbia doing the training that I have on sizing things. And I said, you're familiar with this? And they said, we've heard a little smattering of it. And I said, this was back in April. I said, so 2 months ago, I said, you got probably about 5 months to get comfortable with it, and then you're going to have to be answering these questions. So it starts out with, there is a gas sensor. And so that may require another control wiring and a sensor that's mounted low in the wall. I'm going to show you some, I think in this group I have some slides of that. And another control wiring that's going to have to be fished to go back to either the indoor unit or possibly an expansion kit, depending on where we talked about those separation tubes. If you have a first floor and a second floor, and then have indoor units on a home or in a building, you may need that shut-off valve kit to shut off the first floor, the second floor, and another one to shut off the first floor, because the calculation is what is the expected exercial the potential dispersal volume is what it's called. When you have a leak, what was that look like? And so those sensors on the second floor would shut off the valve for systems with longer pipe lengths or branching out with our separation tubes on another floor, so as not to go above that total dispersal limit. Yeah, and I can see all the faces. That's always the looks that I get. They go, what? And when I saw this, when the Japanese and our product team and all of them presented this with us, I thought, wow, okay, this is going to be a thing. So then we have a cable that interconnects, and then of course, if you're going to have one of those on 2 levels, then you have to have an expansion kit. So it gets more involved. And for the contractors that, and I know I went through this, when we went from R22 to R410A, it was predominantly a methods and equipment change. So R410A operated at a higher pressure than R22, needed different gauges, of course, had different oil, things like that. But it was predominantly the methods, meaning tools and procedures, recovery and all of that, on using when we transitioned the industry, transitioned to R410A. R32 is methods and tools, but now the other component that all of us have to deal with is the application, because of things like this, where we're going to have to know the room that this head is going into. What's not the height of the room, because we don't care about the volume, it's the mounting height, the dispersal height of the equipment from floor level. For Fujitsu, because eventually we'll come back out with that floor mounted unit, but it's 2 feet up to about 8 feet or 7 feet. And that all matters. So we have to know to make these calculations, and it's done through part of on our design simulator software, how to put those in and actually come up with a system. But it's involved. So if you have these needs, and you say, hey, I need to quote one of these, this is what I think based on what I learned my contractor needs, or a contractor has one, call me, call Kevin, get a hold of Craig, and we'll lay it out. Because in Canada, where I sold a lot of the J4, now the jobs are coming in, and not all manufacturers have that. So now I've got to switch and match our R32 to their R410A, which requires me to quote these types of things. But I do it willingly, because most likely those manufacturers, they are really getting strained supply chains, especially those that are with R454B. And they don't have the product, so I know they're probably going to come back to me anyway, or back to Fujitsu for that project. Does that make sense? Because that is a whole other how to do this. And is that something that, I know we got a couple contractors here, that as a contractor, you would want to have that class to know how to do those calculations? Jamie, you got any thoughts on that? Yeah, that, I mean, if you're gonna use this, it's going to have that. But for the Johnstone people, think about that, and not that you have the answer right now, but maybe talk to your customers. Hey, how knowledgeable are you on this? I'm gonna show you a couple things after this. Not getting into the details, but just what Fujitsu has created to help us through this transition.
And just remember, guys, we have that. We're going to help,
That's correct, yes.
you know, we don't expect you guys to be out.
No, don't want that. But if you don't know that the limb has a weak spot in it. So what I want you to know, okay, before you get too far out on there and it breaks off, stay up close to the trunk and say, hey, what do I need to do if I'm thinking about R32 equipment? Now, what I mentioned about the 4 circuit breaker spaces and the two feeding the indoor unit. If I had a VRF indoor unit and I had a 208 volt power supply, single phase, and I hooked up to it and I put our control on, I could make it run sitting here in this room. They will run independently. Unlike on the H series, where even our 1-to-1 ducted systems, if you had an error, most likely that's going to shut down the indoor unit. On VRF, it does not, because they have separate power supplies. So with that separate power supply, and because we're using 2 extra circuit breakers, we then, if we have a failure with the refrigeration side of the outdoor unit, we can still run the indoor unit and it can still send a control signal to the electric heat or the supplemental heat. May not be electric, it might be a solenoid valve or something on thin tube radiation, whatever the setup is. So keep that in the back of your mind that if that's something that might be needed for the job, needed by the customer, something that they say, hey, I kind of like to have that ducting unit, we can do that. That's something that is with J and of course V series as well. The other thing, well, way too much. Other thing is that I didn't point it out, but on that example building, you kind of saw where the 3 units looked like they were inside the building. Yeah, that's because on our J7S, actually all of our VRF equipment, we can attach ductwork to the face of it, set a function code telling it that we can have some amount of ductwork on the front of that unit and put those units inside. Or in the case I did one with John Stone over in Michigan up on Mackinac Island, if you're familiar with that, it's a big resort island, people live there too, it's the whole thing, very nice. But we had to put ductwork because it was such limited space where they mount them, put ductwork so that it didn't affect the other units around it. So that was inside, but it still needed to have ductwork. But having them on the outside, and I've done this a lot of times on our larger VU5 systems, where there just was no place to put the equipment. It was a sloped roof. It was in a urban area, street sidewalks everywhere. So, okay, let's start looking for a place inside the building and duct that out. If you're going to do that, or that's your application, that's something I do need to be involved in. Because the selection of the louvers and the free area and matching up to the external static pressure of the fan, while not a difficult calculation, there's a lot of things to be considered. Any questions on that? You got any questions, Craig?
No, that's awesome.
Like you were frowning there, like, ah.
No, it's great.
All right, so now we go to J3L. So we're going from, that's just on the R32. Fujitsu is going to be R32 with everything else at the end of this year. So if you have any jobs where you are thinking that, or they're kind of on the fence, say, I would advise that you go to R10, R410 and do that, because one of the other things with R32, it happens more with our 3-phase product, is multiple story buildings. And currently in ASHRAE, one of the requirements is when you go through 2 or more floors, then you have to have a fire rated, insulated, ventilated shaft to put the piping in. And it has to be connected to the outdoor air. So you gotta have a fan in there, or it has to be sized for natural draft. And so that's yet another thing, and I have a building working with the Garbrek Group, Johnstone, West Michigan. They had called me, they got a 21-story multifamily residential using high-end, really beautiful apartments, using the Magic Pack units, 2.5 ton in their 8 apartments. And electric strip heat, these beautiful, I mean, beautiful apartments. People won't stay in them because the heating cost is too high for the electric strip. And it being up 21 stories in Kalamazoo, Michigan. And so we're talking about, all right, what can we do? And I said, the first thing is, probably they want to do it this year because of having R410A, if they have to go through any floors. And probably if they're having that much trouble leasing, then they probably want to sacrifice some interior floor space, make a smaller apartment, give us mechanical room, and put the outboard units per floor on the inside and ventilate the louvers. I don't know if they're gonna wanna do that. I said, well, is it any better than having a smaller apartment, but losing the revenue from rent when all those people move out? And I said, then the other thing that comes into play is that they will be able to do each floor at a time. So if they had an idea of either doing renovations or they only had so much capital money, they could do maybe 21, 20, and 19 as a project. And then when they had more money, come back and do the next and the next. And then they could tie those all together and put it on one of our central controllers or put it on the Airstage cloud, which I'm going to show you. So there's all those flexibilities when you get into a VRF product. J3L is just up from the J series. It is a 3-phase only, available 6, 8, and 10, and currently an R410A, but that 10 ton will do up to 30 indoor units. So as far as a school, that might be a good choice, a church, something like that, but it's available in 6, 8, and 10 ton outdoor units. The only thing is, it does have a rating to -4. So if you think you're going to be lower than that, you may have to go to the VU5, which is rated to -15 Fahrenheit. Let me say this about anything Fujitsu. There are no low ambient heating cutoffs or cut off and restart in heating mode. They are going to run and will continue to run until if some type of other protection kicks in. But they will always continue to run. It's just, we rate this, test this. Fujitsu is very conservative in their representation of their numbers, and they always perform better. I had one of the fellows up in Canada has one of the owners of the rep agency. He has one of our units on some lake or near some lake, and he said they had a lot of snow up there, and they went up to the cabin, check on things. He's walking around, and where's my Fujitsu unit? Where's the outdoor unit? At first he thought, is it taken? Well, no, it's not taken. That's where it's supposed to be. And he realized it was covered with snow. It was literally covered with snow, and in the defrost mode, it would send that heated air, and it just made itself a little opening. And that's how it continued to work. And I had heard about that on I had never seen it myself, but heard about that with others, that they just continue to run. Now, that being said, I want you to be careful on the cooling side. And this happened with the AOUH W9 LPAS R410A product, I think, because we had the 9 RLS2 or RLS3, and many distributors and contractors found that, hey, that is an awesome little unit to put in a data room. had no low ambient cutout. And by just continually using it, they said, oh, that's what I put in. Well, then when we switched that out to the AOUH9 or whatever the numbers are, I was working with some engineers, and they were saying, hey, you give us a match to this, or a contractor would ask me, give me a match to this Samsung unit, to this whatever. And I want to check, all right, is this unit that we were told is the exact match? And it was equivalent, but not equal, because when I looked at the safeties that would knock that unit down, much of our new product goes off at 5 above 0 in cooling, comes back on at 14 above. So if you have a low ambient cooling application for the H series, and you're thinking of quoting a product to your customer, you need to go in the D&T manual under the outdoor unit section in the safeties. And it's very easy to find in the table of contents. Go to safeties, it will tell you everything that will knock that outdoor unit out, that will put it into what we call permanent stop. And if you look at that, you see in cooling and dry mode that there's a cutoff. That's what it's going to cut off at. You don't use that for low ambient cooling. If it doesn't show that, then that's okay. So where does that leave us with the R32? Again, I don't do a lot with the H series, but these are the things I get into on the engineering side application. The 18 and 24, 30 and 36 AOUH KPAS1, if I got the number right, those are all low ambient cool. And then asked, now it's kind of died off when I first started with Fujitsu. Why don't they make a 9,000 BTU low ambient cooling wall mount or cassette? Why don't we do that? Because it has to do with the heating load, or the cooling load is so small. And we remember when I said to you about the outdoor unit having an electronic expansion valve for the indoor unit. When that liquid line runs outside of the building, which it most likely will, even for any amount of length, and you're in that -5, -10 space, outdoor temperature, we are going to subcool. That refrigerant in that liquid line will be subcooled. When it finally reaches our indoor unit and there's not sufficient warm air or enough heat load coming across that wall mount, we are only going to do sensible cooling just if you were running water through that coil. Now we're coming back to suction line where it should be gas, and we could end up liquid slugging the compressor. Fujitsu does a great job of manipulating that, and in that RLS2, I mean, that could happen, maybe it wouldn't, and maybe it was just how it was installed, but we would have to say, all right, you can't have those run outside, they'd have to be insulated, there will be all these requirements. Fujitsu says, no, we do comfort cooling, and that's what we do. However, I have many of our VRF products doing low ambient. So, don't want to get into trouble. I tell that to the distributors, that if you're in doubt, if you forget this process, get hold of Craig or Kevin, and then I can refresh their memories on looking at that. But it's in the D&T manual, outdoor unit, safeties, and that will tell you everything will knock it out. But we are ready to -4. Of course, the advantage to this is the footprint. Maybe you don't have much room as compared to its V series brother there, and far less space. Maybe tuck it up close to the building. You can do that. So I sell again quite a few of these. A lower price point than the V series. So if you have that need for heat pump on 6, 8, 10, you can do that. You do not add multiple outdoor units on J series, on the J3L. It's one circuit with 1, 6, 8, or 10. On the V series, which I'll show you shortly, you can put multiple outdoor units on the circuit. So here we're going to that DU5. So this is still R410A. We're gonna have this available through the end of 2025, because that's what we can't, or you guys can't sell it, or we can't bring it in anymore, you can still sell it. And again, not compatible with R32 indoor units. So we have 6, 8, and 8 ton on a 30 inch by 36 inch chassis footprint. Then we have a 10-ton unit on a 30.5 by 4-foot chassis. And then we have 12, 14, and 16 tons, which I believe are 60 inches or 62 inches wide, 30.5 inches deep. You may be wondering, why do I keep saying the 30.5 inches? Somebody asked me, Reed, why are you saying 30.5 inches? Somebody asked me,
Why are you saying 30.5?
because we can put them inside, and a commercial door is this. So you can, granted, this fella right here is pressing almost 1,000 pounds, but these contractors can get that through that door, and they get up on an elevator and put it in that high rise. How great is that? So again, the flexibility, never turn down or think, oh no, I don't have anything to meet that option. Let's talk about it, because we have all kinds of things. All right, then the U in the number means that this is universal. It comes factory set as a heat recovery using 3 pipes: liquid line, suction line, and hot gas line. But then if you're going to do a heat pump, then you need to go to set 2, which is a dip switch. We talked about it in the training, and we tell it that, hey, I'm putting you in a heat pump application, even though you came from the factory set the heat recovery, it's only heat pump. Make sense? Okay. -15 Fahrenheit rated. It has the base pan heater in it. So if you're wondering, and this, I'm going to say this because of the mini splits, many mini splits out there say, oh, I can go to -22. Okay, yeah, and do they perform at -22? Don't know. Most times they don't. But the question, if you're going to pose one of those systems, or the contractors are going to buy that, is when you get below about -7, -8 on a heat pump product, the defrost cycle, which all heat pumps are going to have a defrost cycle, the defrost cycle is going to do what? Melt the defrost, and that gives us what? Condensate. At 7 to 8 degrees below 0 Fahrenheit, that will create enough condensate and will take enough time to get out of the pan that it probably is going to start to freeze. And if you have that extended over time, now you're going to build up ice. When you build up ice, what does ice do when it freezes? It expands, and you can crush the bottom of that coil. I tell contractors, one of the most important things in low ambient heating products on heat pumps is don't distort the base pan. It may seem like, oh, that's just the base pan. It just supports the compressor and holds up the coil. No, our research and development engineers have spent time putting the holes in the proper location for how that coil is going to drain, so that it maintains the proper surface tension. Water has surface tension, which if you've ever seen a drain line that is a piece of 3/4 PVC that's pointed up a little bit, and the water's rolling out, and it's not going drip, 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 or a stream, it's actually rolling back and then it drops. That's surface tension. That matters in the design of the pan, because we need to get that water out of there as quickly as possible. We also always, even if it's a cooling only application, put our outdoor units, H, J, and B, up on a stand, because if we get snow built up under there and we block that, we have the same issue where we're not getting good condensate drainage from defrost. And so if you sell that heat pump, or you're going to go and buy a heat pump that says, oh, I go to -22 or I go to -15, if it's low ambient below 7 to 8, it better have a base pan heater in it, or you're gonna have problems sometime depending on how much it snows and how low it stays. Does that make sense to everyone? So just pointing that out, because those are the things that electric base pan heater and cost of the equipment. There's just all of those things, and somebody says, oh, this is the same 2-ton or 9,000 BTU unit. No, it's not. It may run to -22, but you have these other things, and I've seen that myself, because I've always sold in the cold states and up in Canada, and only in Ontario before I hit the whole country, and for me, making sure that was understood was very important. So we also go to 5 above. However, I have these systems doing cannabis grow operations. I've had them cooling computer rooms, and these units will go into that -4, -5 in cooling, and no problems manipulating the refrigerant. All right, so here we talk about the base pan heater and the very amazingly, so that's one thing you learned today. I didn't realize that base pan was such an interesting part of the unit. What, isn't it interesting? Come on, I'm really all into that stuff. All right, there we go. That's the extent of making it. Okay, so but that's why you wonder, why are we doing these holes? They tested that. That's what they said needs to be done. So these are single compressors, 6, 8, 10. These are 2 dual compressor on the larger units. Now, whoops, any questions on the outdoor units? So you've seen 2-ton, 3-ton, 4-ton R32, 6, 8, and 10-ton J3L, 6, 8, 10, 12, 14, and 16-ton on the BU5, knowing that you could put the maximum 3 12,000 BTU units to make a 36-ton refrigeration circuit. So if you have a larger building or larger structure and you're wondering, all right, how should that be broken out? Let's say that the building is 48 tons. You could do 6 8s, 8 6s. You want to do something, could be heat recovery and heat pump. You could do 4 12s, 3 16s. However you think you're going to patch that up, remembering that the more outdoor units that you have, the higher the cost is going to be. You've already got your fixed number of zones, because that's not going to change between the choices. You've already determined that, or the contractor's already determined that. But if you add more outdoor units, you are going to increase the cost, even if they're more of the smaller tonnage. But again, a question from you to the contractors to the owner. They're in a hotel and you have more refrigeration circuits that meet the need of that hotel. What do they want to do? Happy guests. When I go to a hotel, I want to be happy. I want a clean room and a comfortable room. If they have more of those rooms on fewer indoor units or on one circuit, and you have an issue with that circuit, what happens? The whole hotel goes down. If you do several or a few, break it up, maybe a third goes down. Are they really occupied to 100% occupancy on all times? Probably not, unless it's somewhere where they've got a convention or something going on. So what that does is, if I were talking to a hotel owner, I would say, or anything like that, I would say, look, this gives you diversity. You're paying a little bit more to have more units than for me to run individual refrigeration circuits. But if one goes down, the whole thing isn't going down. Very important, because before we had 12, 14, and 16, and all I had was 6, 8, and 10, and all the other manufacturers had all these other larger sizes. That's exactly how I would sell it to the engineers, to the contractors when maybe they were coming back for value engineering. Here's something you can do with Fujitsu that they didn't think of, or didn't think enough about the owner or the end user to apply that. So now we go to indoor units and our RVUs and controls. So those are our offerings currently that we have. And this is the multi-position air handling unit, which has a Fujitsu Park number electric heater. Please note, these are all the TLA V2, so this would be an ASUA 9 TLA V2. And that's just the tail end of our current design and our model numbers, including the cassettes, any of the ductless indoor units. It has built in the ability to control supplemental heat. So if you have a job that's all cassettes and maybe as supplemental or backup or something, you want to control that valve and open that up so that they get some heat from the existing boiler that's already built into the unit. You need only buy that connector and then probably a third-party relay to make that work. But those are present on all of these units. None of the other ducted have built-in electric heaters, just the multi-position air handler. Does that make sense for everyone? And if you are selling a 480 volt, say, so my building voltage is 480 volt, on any VRF system, any manufacturer, 480 volt is just the outdoor units. Indoor units and the RVUs will all be, for every manufacturer, 208, 230 volt single phase. So be sure if they're doing their first VRF system that they realize, okay, need to have two voltages, because the other voltage with 480 volt, usually in the US, is 277, one of the legs to neutral, whereas that's not going to work for us. Okay, then with heat recovery, as I mentioned, let me just say one more thing. These are the same units that used on heat recovery as heat pump, and then used on the J3L. Those are all the same. They aren't the same as used on the J7S R32. But when you go to heat recovery and you're putting in the VU5, now you add this third component, which is the RBU. So if we're looking at this system and you're just, even if you don't have specific knowledge or real strong knowledge of VRF, say, hey, I know there's three components that you need to be aware of, and that's the outdoor unit, the indoor unit, and the RBU. So got to kind of figure out where is that RBU going to go. And as you see here, our system and every manufacturer except Mitsubishi is a three-pipe system. What does that mean? Like I said, liquid line, suction line, hot gas line from the outdoor unit. And we can come into one end of this. This happens to be a 12-port box. That is an 8-port box. We have 4-port, and then also single port if that's what's needed. Each one rated for a different number of total BTUs connected to the box and total number of indoor units that can be connected to it. So it just depends on the layout, and this is done with something called Design Simulator, which is a software. But all that I would like you to be aware of is that, okay, when you're talking to a contractor or the contractor is looking at a job with their customer, where am I going to put this third component? Kind of know where the outdoor units are going to go. We kind of know where the indoor units are going to go. Where's this fellow going to go? And where is that interconnected piping going to be routed? So those are all the same types of questions. And then if we're going to branch off, just like you saw with, we're comparing the J series and the mini splits, we have the separation tubes. We will have 3 separation tubes in one heat recovery separation tube kit. And if we're going to take this 12-port and feed everything on this side of Johnstone's building, and we're right here, and then we're going to branch off and put the other unit using separation tubes, and that's going to do the other sections. That's how it's laid out. Any questions on that? No, that seem pretty clear? Not going too fast, am I? Everybody feel good about that? Okay. Now, we get to the controls. So the Z5 is a little bit less expensive than the Kagami. I'm going to show you the features on the Kagami. It is a great control, never be worried about specifying or selecting the UTY RNR UC5 control. It's touchscreen, contractors like it, it's very similar to your other touchscreen thermostats that you're selling in VRF and mini split terminology. Our what goes on the wall is always considered a wired remote controller, not a thermostat, although it can be converted to a thermostat by a function or by a selection setting, because those little grooves or openings right there in the lower right corner is a temperature sensor. But very easy to navigate, to get the function code, to change something, just a great control. If you're, and that's about maybe $50 more, $60 more than, $6 less than the Kagami. And then this, the 2-wire control, the 2-wire simple remote is about half of the price of that. And I do have a lot of distributors that will quote that control. And then when we get out of the job, nobody really likes it, because if you know some of the mini splits and some of our older controls on the H series, you had to push the temperature up button and the other button and do this, stand on one foot, and you would access this menu. That still shares that kind of technology. It's just, I hate that, because I think that looks like it's back from 10 years ago. Whereas the C5, once you put that on the wall, wow, people really like that. And then, of course, we have our wireless remote. And that one now in the newest model, and I didn't show the slides on that, but that is now going to have a backlit display. If any of you have ever received complaints that, especially from elderly customers or occupants, that I can't see it because it's dark, or I can't change the temperature when I'm watching my favorite movie because it's dark, we now have that backlit. Then we go to the Kagami. The Kagami is the latest and greatest, and it really is a nice control. There is the Fujitsu remote setting app that can be downloaded from the Apple Store or the Google, whatever you call the Google thing. And you can set up, have multiple setups for your installations. So if a contractor is installing the same type of system and they already know their setting on your smartphone, you can have that default setting for, all right, this is show me ductless is their standard setting for this model, and save that. And then you go up to that control on all of the different indoor units and hit that. It will do a Bluetooth connection. There will be a pairing procedure, and then you can upload those changes and you're done. No more finger pushing, so it saves speed. But you still can do that if you want to. It is a swipe screen like your smartphone. So you're going to swipe left or right to go to different menus, up and down to change values. And this is kind of what that looks like. Sliding your finger to change the fan speed, change flicking up or down to change mode, and then of course temperature, and then turning it off and on. The other thing that it does, and it's kind of funny, even on commercial jobs when I'm dealing with the most rusty union pipe fitters or installers, you know, those guys, nothing gets them excited. Yeah, whatever, it's just another day on the job. Except when they find out that on this, that they can upload through their smartphone a JPEG and then put the customer that they've been working for, their customer's logo right on our controller. This is Bard Manufacturing, that's over in, I believe it's Bryan, Ohio. They make wall units, not sure whatever, other types of air conditioning equipment. Well, they remodeled and expanded their offices. And the contractor said they wanted VRF, they wanted heat recovery, and the contractor said, "You want to use Fujitsu?" And they said, "Great." So we went in there, and this was the thing that they were excited about the most. Meaning, regardless of the system, look at this, oh my gosh. And Craig just sold a school, and when we showed them this, that we did the install training, because they have the, Collinsville, the, K-Hawk, K-Hawk, Chief K-Hawk, is that what it is, or? So a seat with the Chiefs, the silhouette of the Chiefs face and headdress. I said, oh, well, if you get it in the right JPEG, it has to be small enough. We can put that on the controls, and when the control is done being used and it goes to blank, that's what it's going to display. Oh my gosh, the maintenance guys were looking at me and said, that's the only thing they're gonna care about. Why can't we get those through all the school? But it really is a cool feature. Or you can put your company name there. Most don't, but you could if you wanted to. It's JPEG. If it's residential, you could put the family face, or something funny, whatever you can create in a JPEG. Hey, don't forget about that, or whatever you want to put on there. So it's kind of cool. So then we have, along with that, is various controllers for larger projects, and some are for smaller. But if you have BACnet on a job, we use a BACnet gateway, a BACnet converter. And that would communicate directly on the BACnet protocol. If you have BACnet IP, or sometimes people will be using BACnet MSTP, we have another one that is on this slide that just came out earlier in the year that allows us to do BACnet MSTP, and I think also IP, so that probably that one will go away. Then if you have a Modbus control system or a proprietary LawnWorks control system, we have those adapters. We have the central controller that I mentioned, the DCGYZ3. What's great about this, exceptional price point, and let me say on the Kagami, all that feature on that Kagami is only about $40, $50 more than that Z5 controller. So it's not like that. You want to put all Kagamis on there, you wouldn't want to do that. It would cost prohibitive. Sometimes I think, just my own opinion, the Kagami is almost too pretty, typical office space. And so if I wanted to reduce the cost, I would suggest to the distributor, okay, put that in any of the customer facing high profile areas, any of the conference rooms where people outside the company would be present, and then use the Z5 in anywhere where the actual employees for the company are going to be situated. But this controller, up to 100 indoor units, but this little tab right there, if you press that, and then you press the maintenance screen, and then that will pop up and say, one of the choices will be display sensor values. And then you press that, and then it'll say, do you want to see outdoor unit or indoor unit? If you select outdoor units, every outdoor unit that's connected to that controller, their head pressure, suction pressure, compressor speed, compressor amperage, the current RPM of their outdoor fan motor, the positions of the EEVs, all of that stuff will be displayed right on that controller, right for the service personnel to read out before they ever do anything. And then they can write that down. It's just going to be real time. Write that down, go back to display indoor unit values, and then look at TH22, TH24, which are the coil inlet outlet, the EEV pulse rate. And then for me, I can explain, or if you go to our travel training, they explain what those values mean, and you can determine that, hey, this unit looks like it's low on charge, it's lost something, or something has happened to it. It also displays the error codes, so you can look that up through the Fujitsu Mobile Technician app. And then if you didn't know this, on the H series side, but also on our side, if this is, when you go to this level, that's a little bit more expensive for a bigger system. But let's say you're doing the J7S on a 3-zone system, and they said you're in a school and they said, hey, we want to tie this into our BACnet system. You can put one of these on each indoor unit, and that will allow a BACnet DEC system to see that indoor unit and allow it to be controlled. This, if you have that lone in the computer room, that lone 18,000 BTU or 24,000 BTU unit, and you have a VRF system and you have a central controller, this adapter converter allows it to be a visible zone on the VRF control network so that they could still change fan speed, mode, whatever they wanted to change. And then lastly, anyone know about our third-party interface for using the traditional like a Nest or whatever Ecobee or whatever they are, whatever Honeywell thermostat you might want to use. But anyway, the RWY, Y1, Y2, W1, W2, that type of thing, thermostat converter. Everybody familiar with that? All right, so what that does, if someone says, I am not giving up my Nest, I don't care how great it is, I want my Nest, I love it. Okay, well then you have to put one of those on the system or on each indoor unit that has that Nest or that they want to use that Nest controller. One of the things that I like to make clear about that, and that can be on VRF or it can be on the H series, but the way that works is it takes on this side the R and G and a Y1, Y2, W1, W2, if it's wired that way, and then it turns those into signals because we're going to set dip switches in there that a call in on Y1 means this level of cooling call in Fujitsu language to our indoor unit. When it does that, you lose some of the inverter compressor speed variability, and it works best, in my opinion, if the thermostat that's feeding in is a two-stage heating, two-stage cooling. Because you get more choices with those dip switches such that you get closer matching up to what this standalone third-party thermostat is reading. Because remember that in a structure, the load is always variable. Maybe it just needs a little bit of that compressor speed to maintain that temperature. But when you have a snap-acting thermostat, a true thermostat that just says, hey, I'm above 72 or I'm below 72, when it says I'm above 72, that goes into our controller and we've set it to be, okay, maybe I'm a degree above 72. That goes in here. Well, that call for cooling on our end can be chosen to be a 68-degree set point. It goes to the indoor unit. The indoor unit says, yeah, I look at my return air thermistor. Yeah, I'm away from set point. And it says, I want to be 68. And it sends a signal to the outdoor unit, start to open its EEV. And that compressor ramps up. Now we're ramping up. And then air blows on the Nest and everything looks good. And then it gets back down to below 72 and then it takes that away. Well, that ramp up and ramp down is where you lose some of the energy efficiency. So there's always a sacrifice when you deviate from the manufacturer's controls that it's selected for use with its equipment. Does that make sense to everybody? Because a lot of people don't realize that. And if you potentially have an oversizing situation with a mini split, then that can create a problem. Okay, then we have the Airstage Cloud. This is new. I have several of these installed. If we have,
Okay, we got flyers on.
okay, this is a subscription plan. And so it's going to be charged by the month. It's probably meant more for what's meant for commercial structures, but I would say there's probably some custom homes where people are really into the technology. And it allows you, the owner, to have an account. And I chose this after we have a break. I'll show you what this looks like. And this will you can drill down into that customer's building and then drill into their indoor units or outdoor units. On the indoor units, you'd be able to set time schedules, everything as if you were standing there in the building. But also it has the service and diagnostics selection, which is our service tool software. Now, this is a little different view than what actually our service software is, but it's very, very similar. And what it's showing is this has to be the outdoor unit screen, and anything colored in green is on. And this system is an 8-ton system. It is a VR2, and we can go around the piping. It's diagrammatic. So the contractor can look at that large commercial building and be able to see what's going on with it before he or she ever sends a truck out there to respond to that situation. Because sometimes it's just a unit that was turned off. And then if we go up and we make another selection, we can see all of the indoor units, just like we would if I was standing there with service tool hooked up to the system watching it. Why is that valuable? Because to the contractor, through the distributor to the contractor, and then they are billing the end user. It's about $166, $170 a month. But it is, of course, a monthly fee. However, remember that if your contractors have a maintenance agreement and they suggest to put in the Fujitsu systems, how much can they save on that system alone just by looking at it before they have to scramble a truck? And the whole idea of this is to provide a certain level of control to smaller commercial buildings where VRF is going to come more into play. And that's why, right here, you see this on this rooftop unit. Because now there are other controllers that are available that we couldn't see the diagnostics yet on that rooftop unit, but we still could do the control through the 8650. And that controller then would allow the contractor to go into larger buildings, and the owner says, yeah, these offices are always uncomfortable. And then the next thing that I recommend is, all right, let's have a hybrid system. Kevin and I just did Southwire, if you're familiar with Southwire Corporation. They make the building wired cables and all that stuff, and this is their new plan, or new addition to the plan, a whole new plan in addition to their existing plan. And that's exactly what they did. They have Fujitsu in all the perimeter critical individual offices, but right in the middle of the large office space, these are huge office spaces, they have a rooftop unit. So they saved money on the VRF side by getting what they really wanted to get, which was comfort, and put in rooftop units in the interior spaces, lessening complaints here, but also minimizing their capital expenditure from putting all VRF everywhere. Of course, I got there and suggested they should have used 8-ton ductless heat pumps or ducted heat pumps, but that's all right. But that's a hybrid system. Those are very common in design right now, because trying to balance out all of those things, rooftop units, they've come a long way in their control capabilities, but sometimes, let's face it, they just have a great application and they are everywhere. So, and then in addition to this, there will be other things to control lighting. And I think those are getting ready to come out. Control exhaust fans. So now you have a control system, instead of paying, I don't know, $1,000 a point or whatever it costs now for a DDC system, you can put in the Airstage cloud that's very affordable and keep that end user sticky to the contractor. But it's not proprietary, like the job that Craig sold to the school. Is, yeah, we have the train tracer system, and oh my gosh, that's get out your checkbook every time you want them to come out and do a change. It's just very, very expensive. Every site I've been on that's had that, it has been very expensive. And I don't know a whole lot about it because I'm not a DEC guy. It may very well be worth it. However, it's still expensive to the end user. So, and then Fujitsu, and we've just won some awards on this from some engineering magazine because we've completely eclipsed all the other competition with what we're able to do with our cloud versus all of the other manufacturers. And this is what the screen for a given indoor unit looks like. And can set minimums and maximums on temperature. We can tie into some of our Ventacity, or all of our Ventacity ERVs if need be, and show those. We can make set points adjustments from a PC, tablet, or phone. So it's truly a control system that Fujitsu was developing for those smaller buildings, those ones that are, say, maybe 100,000, probably more like 50,000 square feet or less, multiple stories. Any questions on that? Okay. All right, that's all of that. So while we get a quick break, and I'm going to pull up the cloud just so you can see it live. Maybe just take about 10 minutes if you don't do something and you guys get back to it.
It's okay.
Oh, yeah.
Yeah.
He knows, he already knows, and that's what I did. He already knows, so. That's the thing that we. Gave him the part of doing that. Like some part of the free world, okay, some part of the free. And what I'm curious, what's one better? One, two, part of three. When you go to there and one there. Huh? Or. I was curious like that. Okay.
That's fine.
Yeah.
I would hope that.
That's why I was.
So just a quick show of the Airstage cloud, just so you can see what it is. So I've got it pulled up. This is the site manager. And so maybe a particular contractor's client might have multiple locations. So see, this one I just pulled up is what I'm working on because it's a grow, but it's in Spokane, Washington. But you can see that's where it is. I have others. I was trying to pull up the one in Kentucky, but for some reason my access wasn't working. So, so this is the one, the job right here. So we go, and there's the building. I mean, it has 3 floors to it. They said this happens to be a grow facility. Then here are all of the indoor unit circuits, outdoor unit circuits. We click one of them, then this happens to be a 6-ton with 2 3 tons on it. We want to look at that. Then we can see what's going on with the piece of equipment. We can turn it on and off. And then we go to service. And there's our outdoor unit. And this one's just humming along. It's giving us these graphs. That's what's great about our service tool software right here. If we click others, we can see what is this little jump up right here. And that's because when we hover over it, it was in oil recovery mode. So this is giving you an idea of the depth of information that a building owner would get. But not just that, because that's more important, particularly if it has maintenance staff or the contractor has a maintenance agreement with them. But we would be able to control and adjust all of the equipment. So We can see here, these units are in cooling. And this is the EEV pulse rate. This particular system I'm working on because they don't have sufficient airflow across our equipment. And so we're getting these kind of squiggly lines. So it's hunting a little bit to find a operational set point. But without getting into too much detail, just wanted you to see that and see that it is live and it does work. And actually, what I've been doing on jobs is adding this in the first year, being included in with the equipment, because I come out to commission them and inevitably there's a question as to why is he doing this, or we can't get them comfortable. Now I can log in through at least that contractor's 1 year warranty period and be able to see what's going on with the system if someone's not comfortable. So it's really a very, very valuable tool. The other thing is that, again, it makes that building sticky to that contractor for preventive maintenance and keeps them from having to scramble a vehicle and a tech in order to figure out what's going on with the system. It might be something very simple. And even, I think it's just come out or will be coming out where we will be able to do the F340 hard resets directly through the cloud. So if it did trip off on high head pressure, then we'd be able to reset that remotely, or the contractor would be able to reset that remotely and see, was that just a one-off event because something happened, or we're really have an issue with the system. So just wanted you to see that. And then let's look at this. So this went out. I'm not sure how many of the non-stop people saw that, or who gets it. I don't know. Craig, have you seen this?
No.
This is the use of existing line sets, because this is important for you to know. Because as those R410A systems, be they ours or somebody else's, age out and those line sets are buried, the question has come up from us out of the field that can we use different size line sets? Is that going to affect it? Then what does that look like with R32? And that it was always no. And if you ever called in tech service, that gotta be this size, that's it. All hell to pay if you don't have the right line set size. But here we have this bulletin, and let's just look at this. And of course, we're saying that it's always recommended to use our line set, but there are situations out there when we need to reuse the existing lines. And so we come up with, there's all of this verbiage and I'll get this to Craig. This just came out in February or to Kevin, and then he can get it out to anyone here in the room that wants it. But this is what that looks like. So these are all our R32 units that are here. And it's showing you what we're requiring. And then it's showing you what we would allow based on, see how there's some differences in the pipe length based on different BTUs. So if you have a situation where you're looking at a retrofit, a contractor or you, if you're helping the contractor, you want to kind of have this in their phone or next to their workstation to be able to refer to this and say, yeah, you could use something, let's look at it. Let's see what in the case of this one, maximum pre-charge footage is 49 feet. If we go up, and that's 1/4-3/8 required, and this is on a 9,000 BTU KZAH1, or if it's 1/4 we have roughly the same, so we could switch that. But what happens if we've got to go to 3/8 half? What does that look like? Well, if that line is 23 feet or less, then you don't have to do anything. But if you are running longer than that, because the application, existing line is longer, then you're going to have to add 0.48 ounces per foot of additional line set. Make sense? That's, for me, being 13 years with Fujitsu, that was huge. Because it was always, no, rip it out, do it again, or I got this existing line set, not happy with the previous company, or, whatever the case is. This is the reality that we're working in, and if we scroll down through here, there's the Orion XLTH models and what's allowed there, 9,000 through 36. We go down, of course, you've got to read the little notes down here at the bottom, the asterisks and the crosses. And then there's continues on Centauri series, because we've changed to star constellations to make it easier. And then keep on scrolling down, and geez, there's 9 pages of this, so you get the idea. So just wanted to be sure that you were aware of that and could review this. Now here we're getting into the multi-zone systems. So some of those may come up, and some things that are not allowed, just gonna have to look at that. And then this, so this is new for R32, and the what's allowed for R32 may be the same, but we need these frost-proof types. Have you heard that or seen that coming out? So that's what's in here, that has those holes there. I guess there's something with R32 and frost, but the note right there, R410A only flare nuts are not approved for use R32 indoor units. So got to make sure you're going to use our flare nuts that are going to come with our R32, because they have those frost relief holes.
Those ship with the units?
They should, yes. But that's kind of one of those little nuances that if you don't come to training, then you don't know. And of course, compression fitting use is all right. We've got a bulletin on there if you want to look at that. And then filter dryers, if you're trying to clean something up, remember that filter dryers or inverter compressors, variable speed compressors do not like filter dryers. So if you're going to put one in, contractor's going to put one in, you have to have a bypass loop. Why is that? Because the filter dryer is sized for a certain pressure drop with single speed compressors, like on unitary equipment, a lot of other refrigeration equipment. But when you get to a variable speed compressor, and you're varying the velocity going through it and the pressure available, that's going to change the flow coming out the other side. So that's why we say, all right, it's fine to run it for a short period of time, then you're going to bypass it. Why would we need to do that? Because maybe our refrigerant line flush, we're a little worried about it. Maybe we want to be sure that it got everything out of there that's been sitting there for 10 or 15 years hooked up to another system. We don't know what the other kind of life the other system led. So clean that all up and then run it going through the filter dryers, and then have that within 10 feet, and then bypass it and let the Fujitsu system roll. So I'm pretty sure that's new information for you. Acid testing, it talks about that. And if you have any issues or questions, you can reach out to the application department. So we'll send that out. Just wanted you to be able to see that. And then here is the quick reference guide for the selecting with ASHRAE standard 15.2, which is the residential section. And so what this does is try and pull this up. We have this application, and if anyone would like this, this is the full ASHRAE standards 15 and 15.2, because it wasn't until the A2Ls came in that they made a second specific for residential, because R410A pretty much hit everything residential. And then also ASHRAE standard 34. So if you want this full 20-page guide, this has boiled down the whole, I think it's 200 pages of the 3 ASHRAE standards into what our Fujitsu engineers feel is necessary to understand what's going on, in particular with Fujitsu's equipment. So it goes into quite a bit of detail. So if you're wondering about these things, if you're new to this would be also something that we can email to you that you would find valuable. But then we have boiled that down to the H and J series residential. 15.2 is the residential side of the standard, and what's really required and what's going on here. And if you look at a submittal for one of our H series systems, you will see that most of them, your contractors are not going to have to worry about, or contractors are not going to have to worry about any leak detection systems because they are below 4 pounds. It's when you get above above 4 pounds that you start to get into a leak detection system and or an RDS, a refrigerant detection sensor. So you can see here that MS or MREL, that is the maximum release, releasable amount of refrigerant, referencing back to those shutoff valve kits that we have. And then we have to know the size things on here. What's the area of the room? We have to know the height of the room, and if it's a ducted system. And then if it's a ductless system, we have to know what's the bounding height of that indoor unit. And so this boils all of that down. And then it also, and this is something that I think Kevin's going to mention to you, there's a couple ways to figure this, but let's just look at this table just so you know what you're reading. And that is without air circulation and with air circulation and without ventilation. So Johnstone here, I know, is selling ERVs, HRVs. Those are common in homes, things like that. So when you go and you're transitioning to the R32, the contractors are going to have to be aware that they get some credit for the size of the refrigerant or the amount of the refrigerant based on the size of the system if they have ventilation. So this first section of graphs is without air circulation, one is with air circulation. And air circulation is maybe there's a fan or other blower that's staying on or comes on when we have a situation that would allow air to be moving to keep that R32 from coming together. And you see if you have a minimum floor area of let's say that it's kind of a 10 by 12 room, so 125 square feet, and we're mounting that a wall mounted 8 feet, then without air circulation, we're good up to 9.6 pounds. That's what we look at. And then if we have air circulation, see if come across there, it's still 9.6 pounds. But if you add in, and that's what the top says, spaces with or without ventilation or dilution, and with and without circulation. So we scroll down here through all these different sizes, and you see for spaces with ventilation but without circulation, add 0.4 of a pound for 20 CFM of ventilation, 0.9 of a pound for 50, 1.8 for 100, and so on. Everybody see that? So that's why, yeah, I think going forward, even more than just having good indoor air quality in a structure, where you're going to want to kind of brush up on what are my ERV products? What do I have available? Because that may be something that could be applied in the building to get us below this. Because right now, if you guys don't know it, and I'm learning it myself, I don't know how much the authorities having jurisdiction who are doing building inspections, how much they know about it. What I've advised contractors is if they don't know, then your best defense is, all right, this is what I've done. You have these calculations, this chart, this is how I selected, put it in your job folder, in your computer or at your office. And if the question comes up on inspection and he's not sure, but oh, that's A2Ls, already done it right here. Here's how I've done the calculations. And probably he's gonna say, oh, great. Because sometimes the building inspectors, as we know, are the slowest to find out about changes in individual trades. They're more on the fire protection, things like that. So, and then there's an example here of how they work through. But again, this was produced by Fujitsu. And then something else. So because what also makes this valuable, because we don't have a catalog, and probably everybody in the room knows how valuable our Fujitsu H-Series catalog is for providing information. Short of looking at a submittal, there's nowhere else that I'm aware of to get the factory charge on any of our new models. So here it is for all of our models, the factory charge. So you can see all of these are below that for that less than or equal less than the 4 pounds. So if somebody's asking you, this would be also a good chart to have on your desk. And you can see that when we get to some of the bigger ones, the 30 and 32.5 and 3 ton, you see now we're jumping up to 4.44 pounds. So typically you tell yourself that if you're using one of our 2-ton products in any of our product categories, you don't have to worry about A2L. That's pretty much it. But again, I'm all about teaching everybody to fish so you know what to look for. And of course, here we're getting the H-Series. Now we're getting into the multi-zone and 2-zone, 3-zone, 4-zone. So we're hovering right here. We're pre-charged to 98 feet. Our maximum charge, and what that means is when all the piping is on that multi-zone. If you've got everything set and at all of our limits, then this is the maximum charge. So you can see this 18,000 BTU R32 2-zone is still under that value. Of course, going back to the 2-ton. But if you go to a 3-ton standalone, it's okay. But if you've got it run out to everything you can do with that multi-zone, you're above the limit. Make sense? Did everybody understand that? Okay, and then J7S, we're always over that, and of course that's why we have all those other items. So that's what this is. And any questions on this or on R32 or what you're seeing here? Is this the first time you've seen this out of any of the manufacturers? I mean, I don't follow what Unitary is doing, and I don't know, what the if the Chinese manufacturers, if you have any of those for Builder Series or whatever, if they're R32, if they're still on R410A, but they got to be doing something. So we'll send this out so that Kevin and Craig, you can get it out to the group. If you have any questions about interpreting it, of course, you talk to the application department or you can talk to me. But if you're not familiar with it, I highly encourage you read through it, kind of understand what it is. Again, this is something that could be gone over the phone, but if somebody calls up, hey, do I need any of that A2L stuff? And with this unit, you say, hey, you're under you're 2 tons and under with a single zone, you're good to go because it's 4 pounds. That's the limit. Okay. Don't have any questions on that. And then there is, let's see if I close out of that. Yeah, let me just show you one other tool that you have access to. I haven't used it yet. But just so you know, it's here. You wanna, tinker with it. So let's. So we have the 3C charge compliance calculator. So if not into all the charts and don't really want to read through the book, here, this is on, I'm on access.fujitsugeneral.com. Everybody in the room should be able to get on this. And I'm under the tools tab right here. And I'm at charge compliance calculator. So you can enter in the product name, again, thinking about that contractor that may have to talk to that inspector, or just for his or her own peace of mind, having that in the job file to know that it was done correctly. But entering this information into here, and then it's going to make a selection, or make a determination, I should say, not a selection, based on your selection of information. And if we click here, that brings up the guide that I just showed you. And if you click here, and then this brings up a tutorial on the 3C calculator. And that's what we've got here. So you're looking through the calculator, there's all these different topics. So it's going to guide you through that. So again, before R32 really starts to get ramped up, I encourage you to look at this. If you think, and maybe Johnstone can talk about it amongst themselves with their customers, if you think a class is necessary to get everybody on board, to understand and discuss it openly, because everybody's going to be in the same boat. And believe me, when all of this stuff, we had this last year, my first time teaching this was in January of this year, and I was introduced in fall. I mean, it's a lot of stuff to keep track of. There's a lot of tools there. So, but it's coming, it's going to be here. Daikin, I think, has committed to R32. Fujitsu is R32, has been for about 7 to 8 years now, worldwide in other markets. So we're very comfortable with it, haven't had any issues with it. So that's why we automatically went to R32. Of course, R454B is a little different calculation and all of that, but similar type of thing. But this is something just like knowing the basics of running a heat loss, heat gain, or this is kind of something you're going to have to know if you're going to be in the industry and know that you're going to install R32 equipment. So talk to the Johnstone folks. Johnstone folks, please reach out to your customers and see, hey, what do you know about this? And do you want to have a class on this? Because it's uniform information. I mean, developed by Fujitsu, but that 4 pound, anybody's system that's below 4 pounds, that means it beats it. But if you don't know how to tell them that, or how to guide the contractor through that, or if the customer asks you, is this safe? If you don't know the background about R32 and what's happening, and how it really flames, how it develops a flame, that's something that you may need to know for sales calls.
So to being compliant, like an 8 series R32 multi-port, like a 3-ton multi-port, it's not compliant right out of the box. So is that just saying you're
Yes. Yeah, you're gonna have to know what room size that you're putting the equipment in, what the square footage is, and what the mounting height of the unit is. And then find out if that's going to need a leak detection sensor, refrigerant detection sensor, because LDS and RDS kind of interchangeable, but one is more the refrigerant detection that would shut off that system.
and that's not built in.
That's not built in except in our ducted units. So and that's what's coming out from, that, multi-position air handling unit, and then also on those slim duct, units. I didn't have a picture of those, but just like I showed you, they all look the same. That one, has that kind of green looking board in it. That's the detection sensor. Which just reminds me, in times past, our slim duct model, you could put horizontally or you could put vertically. Vertical's gone because of the position of the leak detection sensor. So again, you have a long time Fujitsu contractor that was used to putting those vertically because that's what they did. No more because of the leak detection sensor, it wouldn't detect correctly.
But like in a wall mount, where are you adding that?
That would be a separate item that would have to be wired in. Just like in the corner there, and I'm not sure on these, this is the one for the J7S. I haven't seen the one yet, I'm not sure if it's out yet for the H series side, but that would be what it would look like, and that would be an infection, and that would wire back into and that's where knowing about the ERV or knowing about air circulation, you guys, as it says, show me duct lists, aren't gonna be doing duct work. Duct work volume in an R32 calculation comes into play, and you get credit for that. So I mean, it is a whole involved thing, and probably, they said I deal more on the VRF side, but I could just see you're raising, see the gears working in, underneath your head, that you are, wondering, all right, how am I gonna apply the R32 multi-zones? And what is that gonna look like? So, I'll dig a little bit more and see if I've got some information for you on that, because our design simulator software. Geez, this. Allows us to go into VRF or multi-zone and select on the VRF side. And we look at an indoor unit. It's going to ask us, hey, do you want to look at R32 equipment? So with that J7S, these are currently the indoor unit types. And then on these are up to an 18. And if we go to that slim duct unit right here, then we can go up to an 18,000 BTU slim duct. But we click here, here's all those options that you're seeing right there that are the shutoff valve kit and the sensor kit, expansion kits, again, as we're selecting a system. So it begins to have a little more knowledge on the product to get things set up. And then when we go to, I don't know if it's gonna let me access their detail. Yeah. So here it's the required input for R32, VRF safety, optional. And then we're putting in for each floor and then the rooms, the length, the width, of course, the height of the room. And then here's the mounting height, and that's built into that selection software to help do that. So there's a variety of tools. It's just there needs to be training on how to use those. But this is what's coming as the A2Ls are working into the industry and in the market. So that's why it's kind of nice to know those handouts there. So let's see, let's go back. Yeah, so if we look at the multi-zone right here, so yes, we out of the gate, are with a 36,000 four zone, 5.5 pounds, and then maximum refrigerant charge per pound is 6.38. But, okay, let's take that application since that's top of mind. And now this is assuming that your four zone application is using all the refrigerant lines at their maximum lengths, and you've got 6.38 pounds. So let's go back up to our charts and yeah, right there. And we're looking, and so it's 6.8 pounds. So if you have a 10 by 10 bedroom that you're putting one of those units in, okay, unless they have a tall ceiling, you're mounting that wall mount, if it is a wall mount, high, you can have 8.6 pounds without any ventilation. See how this is working? And so, but if you have that 10 by 12 room, roughly, or 10.5 by 12, now, and you mount that thing at 6 feet, because when we go back down to the bottom of this, it's 6.38, but that's at maximum. So when you're out quoting, yeah, you're going to look at that. Everybody see how that's working? So it's nothing, I don't want anybody to get nervous about it, but it's just gotta have that extra check on the job site.
Plus you can get credit for ventilation if you add in.
Correct. And that's where Kevin was talking about, there's, that US vent.
US.
That US.
Through the wall ERP system. So we don't have to do duct work. And what I'm gonna probably do is get Reed and the vice president of that and do a joint class. So we can, I think it's gonna be an answer for it.
Because if you have that, let's say that, well, I'm in a cabin, I don't know. And I've seen some pretty big, what people call cabins around Lake Michigan. I would call that.
There's honey cabins over here.
But anyway, you need to bring in some amount of air. So maybe if you're bringing in, where we look here with ventilation, you could add 4/10 of a pound or 9/10 of a pound for 20 or 50 CFN. So we're gonna have to have that knowledge, and unfortunately, this is the boat that all of us are in with HVAC equipment and HVAC design. Okay. Any questions on that? Was this helpful? Everybody like that? I mean, that, I try not to have you drink from the fire hose of information, because I used to teach when I first started with Fujitsu, before we really had a lot of jobs and we were training everybody. I mean, you'd sit with me for 3 days in Fairfield, New Jersey, and I would tell you everything, show you everything about the VRF equipment. You'd know how external inputs and outputs work, and you'd know the pressure enthalpy diagram. And then we said, okay, no, this is way too much. They can't even retain this. So we kind of went away from that. All right. So, and that charge calculator, encourage you to get on it and just plink around if it's something that, hey, this isn't really intuitive, or I'm not understanding what it is I'm supposed to do, then we could do a class on that as well.
We have your back. We're here to help.
Yeah. Okay. What you call it that? I will.
The sensor for the wall mounts were at AHR. It's a white box.
Yeah.
They mount underneath the wall.
Yeah, but I don't know if that's
Was that fine?
part number out yet.
They haven't released a part number. They showed it at AHR. It looks like a white condensate kind of.
Yeah. Let's So we'll just be, and this will be the last item, unless there's something somebody wants to, go over in particular. But with the J7S, this is that shut off valve kit that I just showed you in roughly a 2.5 ton and a 5 ton size. And this is what it's going to look like. Of course, now it's a third component that would be going into a house. Of course, it's got to be wired. So we're going to go from the shut off valve kit to the outdoor unit, and there'd be a place to wire that. And then power it up. Something else is going to require to get 208 volt power to it. And more connections there. Advance past that. And this kind of gives you that piping idea where I talked about the 2 floors, where you have the outdoor unit, and then maybe this one is for the basement level. This is for the first floor, because that's a pretty broad space. So we have a shut-off valve kit because we have that MREL value, which is the maximum releasable charge that comes from the manufacturer that says that, okay, if we have a leak here, we have to have on one of these slides, it shows we have to detect that leak within so many seconds. And at worst case scenario, this is the amount of charge that we say as the manufacturer with our line set that will leak out into the space in that time. And then that's compared against all the other things. You can see the level of engineering that has gone in to make this thing work with new refrigerant. So that's what it looks like. It's not a small thing on the Airstage side that are on the VRF side. So that's why I'd like the contractors kind of note that. Let's look at these dimensions. That thing is about 5 inches wide on the wall. It's 3 1/8 inches height. It's 1 3/8 feet. So I mean, it's not necessarily an inconspicuous item to have on the wall. And I wanted you to see the location. So being within, there is a shielding object between the gas sensor and the indoor unit. The gas sensor has to be within 22 feet or less. Otherwise, depending on where it is in the space, here's the example. So this is a whole other training that we'll have on installing the R32 J7S. Just thought, now, while we're on the topic, show it to you. And then here are places that you can and cannot install by Fujitsu standards our leak detection sensor. So a contractor is going to have to be knowledgeable about that. And then other things, we didn't have enough to worry about, is regarding substances that can cause sensor malfunction and deterioration. So there's all these siloxane, silicon gas, which is in shampoos, cosmetics, hair conditioners, moisturizing creams, sunscreens, anti-static agents, water repellents, blah, 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 all the other things. So just so somebody knows, and then you can kind of see how this would work. Shut off valve kit at the outdoor unit with 2 indoor units and their gas sensor kits connected in, and then connected back to the shut off valve kit, which is connected into the indoor unit, but we don't have a direct connection from the indoor unit to the shut off valve kit because the sensor is going to record it and create an error message in the indoor unit. That's kind of how it works. So just wanted you to kind of have a little bit of that back. And then there's another, again, more examples. I don't want to go really much farther than this, just so you can just kind of see what's happening. And then the expansion kit, let's see if there's an architecture view, what this looks like. Now, this is, oh, well, then it is possible to trigger other equipment, ERVs, fans, things like that, provide the ventilation. That would probably, I really figure that I'll be getting to significantly more of that type of interconnection on commercial products or projects, not necessarily on commercial or on residential. So that would be it. Let's see. Yeah, that's about what I thought. I would go a little bit longer, but any questions on anything that we've talked about? Was helpful for everyone? That you felt like you learned some things, not maybe not known all of it, but and if there's other things that you want to know about, want to have that class on how do I calculate a room and go through some examples and apply it to Fujitsu equipment, we can do that. We can do that with the contractors. Let Craig know because all I can tell you is because everybody's got it. R32 is here. You're going to be facing it. And it's better to be out in front of it and know how to answer the questions than scrambling when you're trying to get a quote out. Because I've already had that happen when I've had looked at plans, for example, up in Canada, and they want the J4. We don't have it anymore. So I got to do a really quick calculation. Distributor was late getting me the plans. Hey, we still want to quote this. Contractor really wants to quote this. Okay. You know, it's just a whole thing. So here to help you, as is Kevin, to navigate through all this. Don't want anybody to feel overwhelmed or like, oh my gosh. And thanks for all your time.
I got one thing to say, if you guys bring a big VRF job in, and you go, hey, I gotta have to quote tomorrow, ain't it? We're not gonna rush, because it's the only thing it's gonna do is cost us all.
Yeah.
It takes time. We have to build it on the software, so, I mean, I get them phone calls, I need this tomorrow. Yeah,
Yeah,
Yeah.
it's tough if you have something. I mean, my primary responsibility is sales, so I'll do my very best. Sometimes I can look at it and enter something very quickly into our CPQ, our configure price quote website, and be able to get something pretty quickly. So, but if you have a customer that calls in and says, hey, can you get something on this? I need it for tomorrow. Then at least say, well, possibly, because usually I'm working, I get done with this and then I'm at the hotel doing all the stuff that's not in the right day.
yeah.
Oh,
You
yes,
just mentioned that,
yeah. All right, so let's close that,
Craig says this is the room needs to hear it, so
right?
I'm going by his recommendation, so don't blame me.
I don't know why it wasn't in that previous, all right. So this, if you have that customer that says, I got a rooftop unit down, or I've got some type of large condensing unit compressors went bad, and we need to get something fixed quickly. Well, Jitsu has the DX kit. And the DX kit is just like what it sounds. It's a direct expansion application for large air handling units. So if you have a system that has an air handling unit, this isn't a very big one, but a non-Fujitsu air handler, we can provide the electronic expansion valve that we've been talking about that is in our unit in a separate enclosure, and all of the electronics and control that is in our indoor units in a separate control panel, and then tie the piping into one of our outdoor units. We can then put air conditioning back into, or actually taking a heat pump back into that air handler. And so I've done this, my largest is 80 tons, I think, with interlaced coils. Sometimes we can use the existing coils. Otherwise, we would have a new coil size. I do have coil software coil sizing software on my computer, and we can make that selection. But there is, if you have a rooftop unit and the rooftop unit is delayed and they've got to be back in operation soon, then we most likely will have the outdoor unit in stock at one of our warehouses with Fujitsu and a DX kit, and you could begin piping and getting them back in operation. So, kind of what that looks like. I've done them. I have done a J2S, that's the very original, on a 3-ton and just with an Aspen coil, it's replacement coil. So it's not anything that is that it is just for big stuff. But I thought I had, and that's, you go bigger, then we can put multiple electronic expansion valves to pipe to the unit. Everybody kind of see how that would work. So if your contractor says, yeah, we got this 40-ton unit, it's down, and you know, you guys are 8 weeks out, well, you can still have all the same functionality, but not using the compressor section and use our units and turn it into a heat pump as well, although you wouldn't have to use heating if you choose. And there are some, see if I can show you that. I thought that was the one that had it.
So that, it said max, you could hit 168,000, is that 20, 14-ton, or that's the biggest unit you can run through it, and then you start putting them together?
Yeah, that's what they say. I've run that because I've done the hand calculations and run that in 20 tons. So if you had a,
with one EV?
with 2 EVs, but I've gone to 20 tons. Yeah, here's, I might have a PowerPoint somewhere, but this will be fine. So those are the outdoor units. So that's 10, 20, 30, 40 on 2 circuits. That's the building. This was actually done by Johnstone, West Michigan. This building's in Jackson, Michigan. There's the old coil, the old compressors. There's the piping that is there from the original train units. And then there's the air handling unit. That's an old train climate changer. They retrofitted it with a VFD and equivalent motor. And then they wrecked out all of this stuff. And then it also has 100% outside air economizer. These are the old units. Don't you love this? Doesn't look like Snuffleupagus from Dr. Seuss, where I guess they had recirculation problems, but these things, the one crapped out and they're getting ready to do the next. This has been in operation for about 4 years now. And let's go back here. And then I thought I had, where is my control panel? Oh, so I wanted to show you what the control panel looked like. Fortunately, I just don't see it when we installed it. But it has all the same functionality, everything that are our units. It's just like working with one of our indoor units. It's just retrofitting a third party piece of equipment. Oh, sorry. Okay, so the DX kit is, I mean, gosh, Canada just ate those things up as units were going out because they are all about electrification and putting heat pumps on those big air handling units and converting them into at least getting that type of energy, even though they have all this hydro power. So they're very green up there.
So can you talk about how your temperature and humidity control, what are your options on a DX coil? It's like in these big 50, 60 ton air handlers, they're just running 24/7. Because it costs so much money to start those big motors up.
Right.
So how, let's say I've got 4 10-ton units. And I've got a 40-ton air handler in there. We put in a custom nationwide coil in there.
Mhm.
Couple circuits. How does your system modulate to control humidity and temperature? I mean, is it return air? I'm sure it could be return air or supply air set point driven, but do they modulate stage and take turns on the coils like when we get to low load situations, or how does that work?
That's correct, and. Which one? Find that picture. Oh, there it is. All right, so on this particular application, that climate change, of course, all that stuff went out. There's our EEV kits, and there's actually 2 coils, so 2 kits going to 20 tons each. And part of where you see the cables coming out, the black cables, those are the thermistors that go on the inlet and outlet of coil. And then those, along with the return air thermistor, if that's how it's chosen to operate, or we also have a supply air thermistor on this that will operate like our AUUA outdoor air unit that will also modulate to create a supply air temperature. Now, Fujitsu does not have anything that, like on a DOAS system, even our outdoor air system, that runs with any relation to trying to maintain humidity or preheat. You don't have that. So these units are going to measure that return air or that supply air temperature, and they're going to modulate to maintain that. As in this case of the Sky building, there were VAV boxes, and then the Johnstone put they distribute the Pelican control system. So they sold the contractor a DDC system, and they were retrofitting all those boxes because the DX kit also has the ability from a DDC system to receive, I believe it's 4 to 10 volt or whatever that value is, that standard in the DDC world, and send that into our units to throttle back if it feels like it needs less capacity. So, but it's only going to provide based on meaning the sensible and latent load based on the construction of the coil, but there will be no feedback in for humidity.
I mean, when it gets to low load sensibly, you've got 4 10-tons sitting there. Do they all ramp down evenly, or will it kill out 2 and only run 1?
Yes,
And ramp 1 up individually?
that's correct.
That's the problem I've had with competitors. It's all 4 10-ton systems want to ramp down, and then it won't ever kill out. So then they all just shut off.
Yeah, no, we do not have that problem. We are
So it's,
2 separately, there's no connection between the circuits, so we have an interlaced coil, we have, let's say, 20 tons and 20 tons for 40 tons. And this one is staged up a little bit higher, a little bit higher setting. So it starts to drop back and then drop off, and then this one continues on. That's why we don't have that problem. The others are tying them together and bring them all down, which in reality, that's not really what happens, because part of the situation is, well, what's happening in the building? And what does that return air look like? in other systems, like up in Canada, we did a building and, I don't have, got a picture on my laptop of that. But that system was 48 or 68, I forget how we laid that out. And that fed a whole building. And then they staged those heat pump circuits so that one wouldn't be needed, it would drop off. And they kind of had to work with that a little bit. And once they figured out what those loads were for the basic weather conditions, it was off run. Yeah, there's still gonna be separate operating circuits, each responding differently. And to have in Fujitsu, you cannot have two indoor units and two wired remote controllers cross over on two separate refrigeration circuits. Everything, you can have two indoor units that have one wired remote on the same refrigeration circuit, but it can't cross over the two because the units can't control that operation. Does that make sense? So, and they work very well. Wow, I have them out in British Columbia, have them in Quebec, have them in Michigan. There's another one that I'm forgetting. But they are a real solution to have that situation, especially if you have a school where the air handling unit, it's maybe was placed in before the roof went on, and they had that mechanic room, you gotta crawl up that iron ladder to get up to it. They're saying, well, what are we gonna do with this thing? And the chill water's cracking out and all that. Hey, you could put outboard units there on the ground and pipe in and get that air handling unit back to business. Okay, anything else? All right, well, thank you for the questions. Thank you for coming, and Kevin and I will be here for a little bit if you need anything.
Thank you, man.
Thanks, Reed. Appreciate it. You're welcome. Thank you.
Thank you.
Thank you. Yes.
My last part, billboard stuff, like, them, they like. With that.
I do want to
That's
follow
the
things.
thing that I feared me, right?
Yeah. Coil always there.
So even when they sell like one of the meeting, they're going to inside the warehouse.
No. All of those units have everything inside that unit. So that unit, if it goes down, you can't get it. It's still sitting in the roof. So they're saying that you buy this thing, if it gets right, that little coil. Right, which is it's not a functional part, because there's a big lead.
But if I go, I'm just going to say this is.
It'll only be applicable if you can get in everything.
Like the turf places.
It gets pretty wild. It gets pretty wild. Yeah, it's great.
So I just looked at it, like,
They file.
did you have to see?
Unless they change something out, I don't know. Weird.
Like that was explain it.
Yeah, Craig Hall.
Okay.
But that's essentially it, is you can high off a Fujitsu unit, do it, it's kick.
Yeah. And then they don't have some.
Who gave? My son.
Well, it's still short.
From my son, for Connor Gordon.
Yes, I can.
Got it.
Yeah, if he's got some stuff outstanding right now, then maybe get Craig involved.
And it,
Like a meeting with Craig.
that's my favorite.
Both of them.
Cement attachment, shower. Not.